Okay, so we're going to do the example one in SolidWorks using the sheet metal toolbox. So we have our starter screen, and what we do, we create a new part just like as you would normally do. All right, so we in our familiar part screen here. First thing we should do is on the bottom here, click over units, change our units to inch, because that's what the question is. Right, we are custom working in millimeters, it should be inches. Right, so we're in inches right now. Now you will see I have the sheet metal tab over here. But if you're not seeing it, you right click on the toolbars, then you would see sheet metal. And then you click it to make the tab present over there. Right, so again, you click up here, toolbars and sheet metal. Right, so to begin the process, I have sheet metal tab selected, and we need the base for it. And from the base, then we will do all our legs and so forth. So we click on flange tab, top plane, and now we could actually draw our base structure. Right, so just like we did our custom sketching in SolidWorks. So this was 3 inches. Right, and well, we did not have a dimension for the width of it. We will just make it 1 inch for now. Right, so that is our base. Right, so we could come out of the sketching portion. Now it will go to the base flange properties. So this is where we enter our values or our properties for the sheet metal itself. Now in this case, we know our thickness, so we don't need to use the gauge table. Right, so in our case, our thickness was 0.025 inches, which you already have here. And our K factor was specified as 0.36. Now, we could do other things where if we change the subject of the formulas and those equations in the PowerPoint, if you know the K factor, then you could solve for bend allowance, which is what we're doing. But if you don't know the K factor, then you could put in a bend allowance and solve for the K factor. And so you can kind of do the same thing here in SolidWorks. And that is sometimes when we want to determine the best type of bend for a material, or the best type of K factor for a material based on experimenting. So you try bending different specimen with different bend allowance and then determine which is the best without breakage, of course. And from that, we deduce what the K factor is. Right, so we have our K factor 0.36. Our auto relief, we will not be using this. We'll just keep it as the standard ratio here. This also do it if you, instead of bending the entire length, you only bend a piece of it. You know, how does it deal with that notching and so forth, right? So there are videos about this that explains this a little further, but we're just doing a basic introduction. So we are good here. Right, so we can click OK. Right, so we have our base flange. Now what we want to do is have the leg that goes up. So we go on edge flange up here, click it, and now we could select the edge, because this is from where we want to bend. So you could see here now that we have this bending taking place here. Right, so we know that the angle is 90 degrees on the question, and we know that our flange leg, well, we have our flange leg as 2 inches. So we can click, well, we can input 2 inches. Right now, the measurement is from the outer vertical sharp in this case. So that is the mole point that is indicated on the diagram in the PowerPoint. Right, so that is that point that extends outside. In our flange position, where do we want it? Material inside, material outside. We want it to bend from the virtual sharp again. So in our case, for it to match up with our calculation, we wanted to bend from the virtual sharp. Right, so this will ensure that our 3 inches will remain as 3 inches. Right, so we could have a view of it here. You could see the position changes. Right, so in this case here, we know that this line ends here at 3 inches. Right, so we have everything in place there. Can click OK. Right, so that is our bend. That's it's pretty straightforward. All right, so just to make sure everything is intact, we had specified the thickness, we had specified our K factor, but our bend radius, we did not specify that, and we know it was 0.07 from the question. So just to measure, just to make sure, we could actually measure, zoom in, measure, and we could see 0.03 inches, which is not correct. Right, so we need to change that. So to change that, we go back to our sheet metal on the side here. We could right click and click edit. So edit is up here, edit feature. So we could see here our bend parameters, our bend radius is 0.029 or 0.033. So we could change this to 0.07, which was the question value. So you could see that it visibly increased. So if you were to measure this now, 0.07. Right, so that is our bend. Now, if you want to see how this unfolds, then we could go back to sheet metal here and you could go to flatten. So flatten would show us the flat pattern. And again, we could take some measurements here. Evaluate, measure. So you can measure from this line to the edge. So you can see the distance is 1.97, which is in line with the L2 bend line in the solution to the question. Right? So what we will do now is that we'll see how we could transfer this to an actual drawing, which we could print out and actually go into the workshop and do. Okay, so remember we need to save. The save, you can save this as example one. Right, so now we're going to create a drawing file from this. So we come to new, drawing. Okay. Now for our page paper sizes, now we want to get a page size that is similar to our page that we use in doing documents. Right, so that's A4, but we see the A4 here is portrait. So you can click on browse and we want to look for A4 landscape. So that is this over here. I click OK. So you can see here is no landscape, then OK. Right, so to get our drawing or drawing file or model file, we click browse and we search for our part file. Right, and what we want to do is create multiple views for orientation. Right, we want to ensure our flat pattern is there. And we want to ensure that there is a isometric view of it. Right, so we could click OK and let's see how it looks for now. Right, so this is our flat pattern and this is our isometric view of the flat pattern. But what we would really like is a 3D view of the final part. The reason why we have this is because the drawing itself, if we go back here, is unfolded. Right, so what we could do is, could just agree to that, we could actually right click and remove this view. Right, we could come back to here and on have it back to the folded pattern, save it. So now we could go on to model view over here and select our model. And now we could actually create a isometric view of it. Just to show the manufacturer how it looks, how it's supposed to look. And right, so we could reduce the scale if we want, make it a little smaller to make more space. Right, so we could probably go 1 to 2. Right, a bit too small. Let's keep it to 1 to 1 for now. And then OK. All right, so we need some annotations on this diagram, and annotations are dimensions or notes. All right, so we could come annotations, and then we could actually dimension the distance from the bend line. All right, now the reason why we're seeing that here is because the sheet is went back to meters, right? So it's converted back to 2.97, which is what we got. And then we could again dimension from here. Right, so we have the overall dimension of it. Right, so we need to specify here how we're going to bend this. So for that, what we could do, we could go on tables and we could have a bend table. Then we select the pattern. Well, we only have one bend, but we could sort it by different types. We will have it by A, B, C, or 1, 2, 3. Click OK. So we have a bend table here. So just for A, the direction is up. So this here is fixed, and the shorter one will bend up 90 degrees in a radius is 0.07 inches. Right? If we want to show the final dimensions of it, then we could dimension it a little more, or we could add another part. We could say, okay, drawing model view. And so this is the actual that view we want. Right, so you could remove this one. Right, and we could actually dimension to show the final dimensions of the final part. So you can see we get the 3 inches that we wanted. 2 inches. All right, so we could actually make notes. We could actually put some text and say final part, bending pattern. Right. One thing to note is that you would see here that this this is an ISO sheet, meaning that the dimensions were supposed to be in millimeters. Right, so you could change your text here. You go to sheet format, edit, edit sheet format, and you could actually click on the text here, and you could change it. So we could change this to inches if you want. Right, you could actually put a title here if you want. Right, so you could put another note. You could put notes again by clicking note, whatever it is you want to put. Right, so this here is our drawing. Save it. Example 1 video as a drawing file. Right, so this is how you generate. So it's not only about the SolidWorks model file. And this is what I was trying to emphasize when we did engineering design. Right? This is just one part of the story. We need to transfer this to something that we could print or we could send to someone to make. Okay, so now to get this out of here, we could have go to print. Well, I'm converting to PDF. So right, we could click scale to fit, high quality. We could use letter paper, letter normal letter size, and preview just to make sure. Right, so you could see that when you zoom in, you would see the text. Right, and then you could click print afterwards. Right, so then when you go in and click print, you will convert that to a PDF. Right, so this is how we go about doing a sheet metal design in SolidWorks. Right, this is just a very basic introduction.